the Google Doc. And we can start today by briefly recapping what we said yesterday. So for people who were not with us, can somebody with access to the Google Doc open it and share? And can I ask a volunteer for the recap? For instance, Shane.
That's the thing to do.
I can do that. I was just finding your email where you linked to the document. Hang on.
I can share it.
Yeah, so we can briefly recap and then go through some of the few action items that we had for established, were mainly contacting people. And for instance, Tyson joined us today, and Stas Babak also may join us in the next hour. Then I already seen that Stefan also made contact for people that could be interested in this project, and so that is marked as done. And I wanted to ask Ingrid, because I added now to the Google Doc also the list of people who signed up with the Google sign up form. So I haven't seen your name there. So Ingrid, would you like to be on the mailing list for this project?
Yes, please. I will sign up.
No need to sign up. I will have to copy your name anyways. I'll edit that.
So anything else, Valeria? Are we good or?
Yeah, good to go.
Yeah. Okay. And Thomas is sharing. Okay, good. Yeah. So this is one of the 3 projects that have been brainstormed as good group-wide projects over the last couple of Astro working group meetings that we've had. So this is the first time where we've really sat down with the group of people interested in specific projects, and our colleagues interested in the massive black hole projects are doing the same right now in parallel, and just really try to organize ourselves. So yesterday, we kind of went through the brief description of the project, which you can see up at the top of the document there, which of course led to lots of discussion about what's the right thing to do, what kinds of things will be obstacles, as well as spawned lots of smaller ideas or ideas about other adjacent projects that should be done in tandem or following on or by smaller groups. The kind of primary things that we had discussed was kind of how we would organize it. The kind of principal goal here is to organize around some of the more prominent and well-known, or at least widely used pop synth codes that are used to create LISA populations for the ultra compact binaries. We made a list yesterday, which is probably at the bottom of this document, although I don't think we need to scroll down to it. But there are a gazillion codes out there, as many of you know. But we obviously don't have the person power to address all of them or to run all of them. But the question is really, which ones should we do? And we had kind of hemmed and hawed about this, I would say, and settled on we'll use the ones that we have representatives of participating in the project. That's probably the most important thing. But then also we would like to address the ones that are most commonly used, at least currently, for the LISA compact binary populations that we have. Kind of adjacent to this, you know, in as much as we're talking about code comparison, was also the notion that we should really go back to the literature and look at the assessments of the LISA binary population that have been made and do our best to extract from the literature or talk to our colleagues who generated the results in the literature to understand the assumptions, the parameters, the codes used, whatever, that produce the classic results in the literature. And so part of the analysis here can also be assessing how those different predictions in the literature should be intercompared in a very similar way to what we're doing with the code. So you can see there the list of, thanks for scrolling down to that, Thomas, the list of codes that we generated. We tried to put links to the code archives where we could find them. We know where many of them are, and probably we can find others that aren't linked there yet, as well as the papers that describe the codes. Probably the one thing that will be added to this in the context of the literature search then is results derived from all of these codes that also appear in the literature. So the other thing we started to do was just trying to organize people. You heard Valeria kind of cite out a couple of names there of people that we definitely wanted to talk to who weren't currently here. And now many of you are, so it's good to see you here. Welcome. So in particular, for several of the codes that we were interested in, we didn't necessarily have people with us yesterday who could represent the codes, and so several of us reached out to them. I emailed Ash Reuter and Katie, and Stephen. I don't remember who you were going to look at, Stephen, but it's not right there in front of me right now. So, but we did start reaching out to people, and so we will slowly assemble some people around us on those fronts. The last thing I think probably is important from the discussion of yesterday, and I see Tyson here, so Tyson, that's great that you're here, was kind of discussion about what we think the right thing to do is to intercompare codes. How do we agree on what the inputs are? How do we then take the outputs and decide that they agree or disagree? And so part of that will involve just kind of assumptions, whether they're realistic or not, about the astrophysics we start with, and then part of that will be based on how do we do the assessment on the back end, whether it's about the full population or about the LISA cut on the full population. That will necessarily involve our colleagues on the data analysis side. So I think that's everything. Anyone else who was here? Did I forget something critical?
No.
Rock and roll. Okay. So generally it's been a little bit of a free-for-all as far as discussion has been going. But in terms of, yesterday we made a gigantic scope of things that we could or think about or could talk about in the context of this project. So we agreed that the literature search was something that we could certainly do kind of offline and over the summer, especially once we move into the parts of the summer where everyone's on holiday, with kind of end of the summer as the goal for there. But we should also kind of start organizing ourselves just in terms of how we're going to communicate regularly, how often we'll get back together, and when that schedule should start up, especially with the summer holiday coming up in the way. So I don't know, we don't really have a chair in the game here. I don't know if Valeria or Thomas wants to do it, or I can certainly do it remotely from Zoom, but I'm happy to do however we want to do this.
Okay, I'm happy. I missed a little bit because I had to fix something in the next room, but I'm happy to do whatever has been said now.
Oh, sorry. What did you say, Valeria? I'm sorry. Did I misunderstand what you just said?
I was away to fix a problem in the room next to ours, but I'm back now and I'm happy to do whatever.
Oh, okay. I thought you said you were taking over guiding, but that's fine. Yeah, I was asking which one of us was going to chair. So I'm certainly happy to chair if you're going to have to run off and take care of our problematic massive black hole friends. So.
Emory. Yeah, the birds.
Oh, the Emory people, right? Yeah. So, okay. Okay. So yeah. So I think in my mind, probably the critical. Sorry, my cat's in the way at the moment. Zeno, get off. Okay. the kind of primary thing in my mind right here is if you look at the long list of codes that we have there, there's many of them that have traditionally been used. There's lots of them that many of us are using ourselves, or colleagues who aren't here are using. But as we said yesterday, there's probably far too many of them for us to kind of completely assess here in this project. And so one thing that I think in the back of my mind think would be important is that when we start talking about the assessment, even if we will narrow it down to just a few codes, that we do have a good framework that is clear on what we did, so that if some future iteration of these codes, or our colleagues who are working on these other codes wanted to come in later and then kind of put their code in the mix or compare it to the codes that exist, there's kind of a well-established framework and a well-established criteria or evaluations that we did, so that they could make meaningful comparisons post facto. I think, Sylvia, in my mind, you're the one who's done this sort of thing before, so maybe you have opinions on how hard or how difficult that is to do. But and I see you have your hand up. I'm sorry, I wasn't looking at the participant list. So
yeah, no worries. Yeah, definitely. Of course, we have experience doing this. Yeah, I can say more about the popcorn project, maybe about at some other time, but the short thing to say is I think it was a project that took us about 2.5 years. And I think 1.5 years of that was just trying to figure out how to compare codes. So I'm very willing to share our experiences with this, just so that maybe here we can avoid some of that really delay in doing this comparison. But there was something else that I wanted to add as well, which is a little bit related to the popcorn project. But I think we should also discuss maybe a little bit more concrete what the aim is. Because if we just talk about code comparison, then part of that, of course, was done by the popcorn project. And I think there's not so much that actually has changed on the evolution of low mass stars. And so then the question is, what is specific goal of this code comparison that we're adding? So is that all of the new codes that have popped up since then, how they compare to those old school popcorn plots? Or do we want to focus on the mass range that popcorn did not focus on? So we only looked at binaries that may potentially have white dwarf components, but there's a whole mass range above that we didn't look at. But yeah, it's, I might have a bias there, because I think the majority of sources for LISA would be the white dwarf ones. And the other thing is, our focus in popcorn was not super detailed on the double white dwarfs. And I think if we're really trying to understand where the differences for LISA comes from, then maybe that's the angle that should come. And lastly, of course, LISA is a subpopulation of all double white dwarfs. And so I think there's all of these different angles that we can approach. And I think it would be good to discuss this, in which way it's different from the popcorn work that has been done.
Yeah, so I see you have your hand up, Tyson. Let me just add to that for something that was said yesterday along these lines for those who weren't here. So Heiss, who was with us yesterday, very strongly advocates that right now what we should focus on is the population with the most sources, which means the double white dwarfs, right? And then the way he phrased what he thought the good objective would be is to define what the uncertainties in the LISA band are for the population. And so we can take that how we want it. Maybe it's number of sources, maybe it's overall amplitude, maybe it's the size of the confusion, but kind of bounding uncertainties, which will help inform what we're doing in LISA is a good goal. And astrophysics will naturally flow from that, because the uncertainties are bound up in our astrophysical uncertainties, I think. So that's what was said yesterday. I'll not blither on about that. Tyson?
Can I just add something to that?
Oh, sure, of course.
Like if Tyson also has a comment on the same topic, then of course I don't want to interrupt. But
Well, I don't know if it is a comment. I was just going to say that this is, I'm not familiar with this popcorn comparison that you all are talking about, but I think for the context of this discussion, the place we want to compare the codes is the LISA observables. And I'm not sure these comparisons have focused on that part of parameter space. So maybe there's, you know, lots of data in the can that can just be used, but we just need to change which part of parameter space we're focusing on when we compare these things.
definitely, yeah. When I had to miss unfortunately the discussion from yesterday. My master's student had to give his final presentation, so
No, you're okay
for that.
There's a recording, you can listen to it.
But I completely agree with what Gijs was advocating. But is this a made decision? And if so, shall we then write it down in these notes as well? Because I think that's a very big step, actually. That's a very big decision. And I couldn't find that so far in these notes.
This is really seriously the third hour that we've spent as a group talking about this, right? So I would say nothing's a made decision, right? Part of the goals here in the working group meeting for all of the big projects is to put all of us in a room together to see what we're interested in, to see what we think is possible and doable on short time scales, right? By which we mean a couple of years, right? And if it's going to take us 10 years to do something, then we need to grab off something smaller, right? But really the goal is to narrow, to among ourselves decide what we're all willing to work on together. As we kind of said where the chairs introduced the projects, there will be smaller projects that groups will want to go and do. But the goal here is to define the big project that's going to take all of us to work on. And so nothing is said at this point. We're just talking about the parameter space of projects that we could work on and trying to figure out where we all have the common interest that says, yeah, this is interesting enough, I'm going to spend time on it. We think it's important enough to spend time on it. And with the expertise in the room, it's a project we can do. So I would say nothing is settled, Sylvia. And the goal here is to advocate for the things that we all think are important and interesting. And we will, over the course of the next, I would assume, couple of months, zero in on specifically what we're going to do. Maybe not that long. We'll see how things go. So,
do people agree with Gijs? I would.
Yeah, I certainly do. Yeah.
I wanted to add to this about yesterday's discussion. Right at the end, we sort of gravitated around the LISA detectable binaries with wide world components because most of the people present were either working or, well, were related to that topic. So there was we didn't have many representatives from other LISA sources influence the discussion, right?
Alexei, you have your hand up.
Yeah, so just yeah, to comment on wide works, I mean, I think the point was that just is the dominant population, but I mean, of course, there are other interested populations. But I mean, I think the point is to really make a range of what possible foregrounds LISA will see in terms of wide dwarfs and sort of like, and that doesn't really necessarily come to just code comparison, but it really like just about bracketing of possible like minimum and maximum, for example, number of sources that we'll see. And I mean, that also includes the possible uncertainties from the galaxy or from the prescriptions for binary evolution. And then once they are all the same for all the codes, also uncertainties from the different codes predictions. Yeah, and just another comment is that since the popcorn project, apart from that, it wasn't specifically on LISA focused. I mean, I think another point is that there's been also quite a lot of observations of short period binaries, which potentially could be constraining for this project. So I mean, if LISA predictions are made, probably it's good that the predictions are also in agreement with observations of existing sources.
Yeah, we talked a little bit yesterday about constraints as well from outside, right? So EM observations in particular. And so in as much as these are random simulations, right, the resolvable population will fluctuate a lot, but I think matching on, or at least constraining the input parameters to the models from those observations will be critical Thomas or Tom or some of the other observers here may tell us what they think is reasonable to come from the EM side at the moment. But maybe also we should think about what they might find useful coming out of the code comparisons from the multiple simulations. So
as I said also yesterday, I started a document to summarize kind of what observational benchmarks or boundary conditions we have and where selection, I think that's probably a big, but otherwise a problem. It's scattered all around different papers from different observers and stuff like that. So I said I will start the document and then maybe share it with the others to add and make sure that the people really then theorists working on this project in hardcore then have kind of this as a living document. More or less.
Yeah. Tom?
Right. I think Kevin's searches for very short-term period binaries is a very important constraint that hasn't really been fed into the constraints on the LISA population yet. The difficulty there, I think, is, it's one thing predicting numbers and periods, but you've actually got to predict the properties of the stars. Sorry. And, like the one Kevin was showing today, is a very unusual system, that one with a very deep eclipse. And it's not really very easily predictable, that, but so the comparison with EM observations is actually very difficult. I think it's more difficult to compare a given binary population synthesis population with the EM than it is with the gravitational waves in terms of predicting, because you've got so many funny effects that can happen.
Yeah.
But maybe that system is also a bit of an outlier, right? The average system won't be. I mean, they're just the ones which we easily find, right? These are the low-hanging fruits.
Yeah, quite possibly it's huge selection effects, but on the other hand, it's one of the few we have there. So until we found a whole slew of normal ones there, we can't say it isn't the standard one. There are the tidal heating effects or something, or past accretion or something that could affect that system. It's complicated, that. So that comparison with the EM observations, I think, is difficult but quite important.
So what I wanted to caution is that we do not want to broaden too much. This is Tassos. We don't want to broaden too much the scope of the project that we described.
Right.
I think if you start adding there code comparison, galaxy model comparison, and comparison to observations, then that's not a project that leads to 1 year.
No.
It's not well defined, and it's not something that is one paper. I think what we described yesterday can be one paper. So what we want to calculate is compare different codes, select a few different physics configurations, and a couple of different galaxy / transformation models, and see what is the foreground prediction, what is the range that we're getting. It is a well-defined, very useful project.
But then I may, as an observer, may say that we may have a foreground prediction, but it might be completely wrong if we don't put any kind of boundary conditions from EM in there. Right? I mean, then it's about.
I think we need to formulate another project that studies something well defined.
But
that's or not that is not useful.
Then let me say it differently. I would caution to publish foreground predictions what other people will use then, if we know they might be completely wrong. I fully agree with the code comparison and all this kinds of stuff, but then making like predictions for observables, where people then go on and say, "Oh, I published paper based on these foreground predictions," that could be dangerous.
Then we should leave that for 3 years from now after we have done 2 other projects. I'm not necessarily against, but I don't think we should put them in the same bag.
Yeah.
So Tassos, let me ask you, because yesterday you were talking about this again, right? So the once we get to the point where we're going to say this is what we're going to do for code comparison, right? I think yesterday, and I agree with this, you were advocating that the critical thing will be that we all have inputs we agree mean the same thing when they go into those codes, right? So that's all sorts of stuff. It's metallicities, it's space densities, it's mass and period distributions, all of those sorts of things. Do you think we should be using classic descriptions for those values that have been used in the literature, or do you think we should create a modern set of those assumptions which fold in what our observational colleagues might be willing to say right now, and then use that as the foundation for the code comparison. Isn't that a
Personally-
middle ground between what you're suggesting there be two papers?
I think I either don't understand exactly your point. If we are talking about the galaxy model, I would certainly advocate, but not too strongly, to move away from simplistic assumptions and go to one or two models from different ways of figuring out star formation history of the galaxy.
Okay.
Chemical evolution or so one or two models that kind of like cover our best current understanding. I think that the difference between doing simple like constant star formation and doing something more complicated is very small in terms of how difficult it is to be done. But I don't think this is covering the concerns of other people that we need to calibrate to the observed population.
Right.
Yeah.
Okay. Yeah.
And if this is a question for Thomas, for instance, because he raised this concern, like would the model that we developed based on NAMA's observation be a good like comparison?
Maybe,
If we
yeah.
if we look at it, we update based on your living document of
Yeah, I mean,
reasonable measurements, and we try to implement similar star formation,
Yeah.
similar everything as PPS, and we sort of keep it as an
I
alternative.
think that's a very good example of Namas and Valeria's work. I agree, that's a very good example.
What is the name of some sample?
So that's the plot that I showed yesterday. Basically, we estimated the LISA observable population and the foreground based on the measurement of double white dwarf separation distribution and double white dwarf fraction from spectroscopic sample with some assumptions on top. Yeah.
Okay. There was a flurry of hands. Tom, you lowered yours. Did you want to say something before I go on to Alexei?
Yeah, I was just going to say, I think it's obviously a very good idea to agree on a standard set of inputs. That there's no doubt about that. I think it's more downstream. I was just thinking it'd be nice to have some testable outputs. Obviously, the LISA outputs will be testable in 15 years or whatever, but also, testable outputs against existing EM things. I don't think we actually have to go and make the comparison, particularly in a paper like this, but just say this is how many double degenerates or whatever we would predict between these period distributions, and just let later people sort of test that later. But I think it's quite important because they're not necessarily that easy for someone else looking at the paper to extract those sort of things. And so I think it is useful if those sort of predictions could be made somewhere, and you don't have to go and try to sort of rejig the initial inputs in the first place, just as long as they're consistent across all the codes being tested.
Right.
Yeah. You want gravitational wave frequencies, or are you thinking EM periods?
Well, both. I mean, because the key thing will be to predict the LISA background, right, and the nature of the. But all with that same data, you can make the EM predictions as well. I would have thought, but
that's kind of the thing, right? We do a model, and all of that information is already there. And I think most of us, if you contact us, we're very happy to share that data. So I guess there's a bit of miscommunication on.
But then,
whether or not the data is available. So then we need to know very specifically what you want.
Well, exactly. But that's why we should be discussing it now, because if you've got 10 different codes, you can't expect some random person to go and contact those 10 different groups and try to work out what their original data. I mean, that's really difficult. Why not actually do it?
Isn't it kind of this? Sorry.
Try to produce this stuff in a more direct way for the observers. I mean, rather than expecting them to go and contact everybody on the paper, it sounds a bit
Isn't it kind of the same for us? Because we're talking about comparing two observations, but there's also not one set of observations. There's multiple sets of observations and different samples, for example, like if different double wide dwarf space densities. So
Yeah,
my
but-
models are in between all of those. You know, which direction should I then move?
Well,
So
you can,
then also
you can
we-
make some
we are-
fairly, there's some fairly obvious ones to make. I don't think you have to try and compare against all the observations. You should just be trying to
But
sort
maybe
of
that's
say.
obvious to you, right? How does a theoretician decide which observations are clearly the obvious ones to compare with?
But I mean, it's funny because the whole thing here seems to be getting your codes to agree, but not to agree with reality. But it's really not easy to use the output from a project like this from an external perspective. If you've got multiple different codes in it, I just don't see how one could engage with it really.
I think the thing is that for this project, we're trying to collaborate between all of these different codes, while the comparison with observations is, I mean, I can probably speak for all codes, but definitely for the SIBA, that we try to compare with observations as much as possible, right? Pretty much every paper we write is based on that. But then, right, so I think those comparisons with observations are more individual projects, more than, you know, what we can achieve in this collaboration right now.
Oh, okay. I mean, the whole document read very strangely to me in the sense that it was very much about the code, and reality seemed to be almost immaterial, but that's okay.
So
it's really going to be, it's going to be very, very difficult to, as the way it's set up at the moment. I don't see how observers are going to be able to use it very well, because there's a lot of details in actually converting from the output from this into predictable data, and I just don't quite. I mean, maybe there's some way to define it in a way that will make that easier than I think it's going to be. But
so let me just interject a comment in here, right? So this conversation is one that happens often, and the sociology of interfacing our community with the theory side and the simulation PopSynth community and the observer community is something that many of us think about a lot on many fronts, whether it's simulations like this and pre-LISA comparisons or post-LISA observations, the sort of stuff that Tyson and the LDC and the catalog people think about very often is what exactly is the useful data going both directions, and how do we present it in language that we can all access and understand. And so I think projects like this are good proving grounds for us to exactly address as much as we can what the high level issues there are to begin laying the groundwork for that, because this will have to get figured out by the time we have LISA data in hand. And so I think a natural part of what's going on here should necessarily be having more in-depth conversations like the ones that Tom and Sylvia are having right now, specifically so we can address these issues, because I think they really are pointing at the critical fact that we don't know how to read each other's literature and how to take each other's results and use them for our own nefarious purposes, as it were, although it's collaborative purposes at the moment, right? So okay, I'll go to Alexi, and then I saw you put your hand up again, Sylvia. So
yeah, right. So I mean, I just wanted to say that regard to what Tasso said and what followed from that, I think that when you do code comparison, it's not that hard to reproduce observables. In fact, I mean, like if we produce these background, for example, we can just as well produce, for example, the total population of white dwarfs and their uncertainties, and also the populations of progenitors or something like that. It's very easy. So I mean, I think it could be very easily the subject of the same paper. What is difficult though is to explain the observations. I mean, so how to say, explaining observations at once, for example. So I mean, that could be a separate study. So I mean, like just like producing the LISA background and saying, okay, we're very good at explaining white dwarf population which you observe, but we're pretty bad at explaining the eclipsing sources. That's quite all right for a paper, but I mean, like explaining all the observables at once, that's really difficult, and probably could be a separate project. So just being very clear what observables we explain, which ones we don't.
Yeah. And in as much as, we make assumptions for where we're directly testing the codes to start with, right? I think that's where a lot of those conversations will happen to start with, right? So, okay. Sylvia.
Yeah, I think what this discussion is also showing is that there's still a lot of work to do before Lisa, right? There's all of these different aspects where there's uncertainties that we want to investigate, and all of them are really worthwhile. And I think that the difficulty is that they're all intertwined, right? We need the observations to constrain the models. We also need to understand why there's differences between the models in the first place so that we understand where the differences come from. But that's not only the binary modeling, that's also the star formation history. So we have all of these, but doesn't that mean that we should split up this project that we're doing in sub-projects where one focuses on what is the coherent message coming from the observations? One focuses on, you know, the galaxy models like Tassos was explaining, where maybe the binary population you take very simplistic, but by taking it simplistic, you can actually focus on the differences of the star formation history. And for the binary population, I mean, I always want to compare as much as with observations, but if we want to understand where the differences between the codes come from, that's a very complicated project by itself already. So shouldn't we just like split this up in multiple sub branches? Because we need to disentangle in order to make progress.
Yeah, I mean, I think that's an important question, is how to define the scope of, I mean, back to Tassos's original point, right? How do we define the scope of what do we want to do and we can get done? I think there is just a little bit of danger in fragmenting into too many small projects too early. So we have to decide, is there an overarching theme that needs to be done first to enable all of those other things that we think are important as well. And so that's part of what these initial discussions are all about. But you're not wrong, Sylvia, right? There's plenty that needs to be done, and certainly plenty of things that need to be addressed, because they're all issues. The question is, can we prioritize as a group what the big ones are? So there's a hand in the room. Oh, and I see Heis has joined. So Heis, we're in the middle of deciding what's important to do and what's not important to do right away. So, but the room has their hand up.
Yes, so that's me.
Okay.
I agree with everything that has been said so far, but I wanted to back up a little bit, Tom. I think that if I understood him correctly, what we can do without going too much into comparing with observations, there are some quantities that will come anyway naturally from all our simulations, right? I don't know, for instance, the birth rate of some source, or the merger rate, or these sort of things that observers also estimate. And if we table them somewhere, I think these things will come naturally anyway, just the matter of putting them clear somewhere so that they are easily accessible and visible. That's it.
Yeah. That's good.
Jan, you have your hand up.
Yeah, sorry, I'm joined a bit late to this discussion, but about comparing to observations. So we also had discussions about the pre-LISA EM work, and there I signed up to do calibrating models with observations. So I agree that's a separate thing, but I wasn't sure how that fits into this, because I thought we decided that would be a separate project.
Yeah, with the beginning of this conversation, which you may have missed, was we were talking about, if we start down the road of intercomparing codes, we're going to have to establish initial data, initial parameters that the codes, so that the inputs to the codes we think are all the same, and then what the constraints on those should be. And I guess maybe interrelated to that, discussing what the outcome of what we're calling code comparison, but really it's code output comparison, right? But what that should be. Should it be, focused on certain populations? Should it just be focused in the LISA band, et cetera? And that sparked the discussion about comparison to EM observations. So,
right, yeah. So that is my second kind of question. I guess the issue is that the modelers generate very nice model populations, and the observers produce very nice observed populations. And I think the challenge is whose job is it to convert from the model population to an observed model population? And I think that's actually the task of the observers, because they know their telescopes and their selection methods very well. So I think it's a task of observers to bridge that gap, but that's just my opinion.
Okay. Heis, you popped your hand up.
Yeah, Sylvia is saying the same. I always said, oh, it's the task of the modelers because we know everything from our model systems, right?
Right.
And so in principle, you can from them much more, because it's very difficult to come up with selection effects of objects that you have never seen. But in practice, I think you're right that in order to do for the theorists to do it, they have to know, which typically we don't, and so therefore, I think it has to be a collaboration. But it's not simple.
Yeah, and this was Sylvia's point earlier, I think. So yeah. Other comments on this point?
Also, maybe a clarification. I think it's true. Is everybody aware of these two half overlapping projects that are now started? One is coming from the question, what should we do in terms of pre-LISA electromagnetic observations to help LISA? And this one is about what's basically the uncertainty on the LISA foreground and the galactic population, and along that same line, very interesting question, how well do the codes agree and what can we learn about binary evolution by looking at comparison? There's a bit of overlap. And so Jan, I think the goal is slightly different. I would say that for the project 3 of the pre-LISA, it really is to see if there are fairly direct observations that we can do to relatively directly probe the population that itself would be a LISA source. But I think in this, if you ask the question about comparison of codes and comparison of codes with observations, I think maybe a more interesting comparison is to do with sort of intermediate steps that are itself not interesting LISA sources, but might be much more interesting because, one of the funny things that already in a famous paper by Simon Portuguese Zwart about formation of double neutron stars, they had these examples where starting with the same initial O star binary and ending with the same observed double neutron star system, the Hulse-Taylor pulsar, different codes actually had completely different intermediate stages. And so they started with the same, they ended with the same, but in between everything was different.
Nice.
And so that's interesting to, there's something to learn there, obviously.
Tyson.
So I joined this call, I think, with a completely different philosophical attitude. I'm less interested in trying to get the different population synthesis or population predicting codes to agree, and more interested in, let's assume that they're all right, and I want to understand how much they disagree in the LISA observable end. So, to characterize the variance in what we expect from the LISA population. So I would like, us to agree on some sort of basically an API for what these population predicting codes spit out, and just turn the crank on the, using LISA as like a filter of these populations to see what pops out into the catalog, to get an idea for, given what we currently know, because I'm sure everyone assumes that their population predictor is the best one, and to see how much that differs when you see it on the LISA end, and then we can have the big cat fight to figure out which of those predictions is the closest one to the universe. But that sounds like way more work, and right now there's a helicopter going over. Sorry. Right now I'm very curious as to just how much uncertainty there is. All of our intuition has been built off of effectively like order one simulation and its descendants.
Right. Yeah. Stas.
Yeah, just to continue Tyson's line. So I don't want to assume that everyone is right or everyone is wrong. I just want to actually think slightly differently. I mean, there are some astrophysical assumptions which go that in each of these simulation, and of course there are some uncertainties in this. And can we explore these uncertainties and have a boundaries on the worst, the best, and median, or more complicated than that? But it's still in line with what Tyson was thinking, but it's more based on the what we don't know what goes into the simulations.
Heiss?
Yes, well, let me reply to this. I fully agree, Tyson, that this is an important goal. And so what's above the thing we're seeing now, which I think is a first step towards what you want, is that we agreed we would do a literature search and see what predictions there are and what the main assumptions are in these published results. It's only a relatively small number of ones, but at least they are well documented, you assume. And to warn you, I think there's two parts which make what you said maybe less straightforward than you would hope, is that there is actually a lot of heritage between the different codes. And so trying to map out what the uncertainty range is in your assumptions is actually very, very difficult. One of the things being that we could have, let's take common envelope. And so I once asked the statistician, I said, I have this problem, right? I have a description of a common envelope with the parameter alpha. And I would like to do some, some observational tests. And the outcome is the value of alpha or the fact that the prescription is wrong. And then he said, well, that's a very ill-posed problem, right? Because the parameter space that your prescription is wrong is much, much bigger than the one that you're right. So you'll always find that your prescription is wrong. Unless you start doing something, you have to have an alternative. And so I think, we can do and say, if I change alpha between 0.001 and 1, or let's be generous, 4, we can, of course, find out what the impact is on the LISA foreground. And it may be interesting to do this. But then there are many other things, and it becomes actually quite a big project. And I think many of us who have done this game is that if you start observing with comparing with observations, then life becomes slightly more manageable, because at least some of the things that you may want to do turn out to be, not realistic. And so I'm not saying that we shouldn't do what you want. I think we should appreciate, because I think it's one of the reasons we do this, and also the project 3, right? We want to get a better handle of, this bump in the LISA foreground. Can we get a little bit more idea of the uncertainty on that, just based on things we already know? But I don't think it's as simple as it may sound.
Tyson, were you going to respond? Is that what your hand's for?
Yeah, it was. So, so this is an interesting example. Like you have one knob you can turn, and you can dial that up and down and see what happens to the population. And the problem here, right, is that you have way too many knobs to turn. So it's a lifelong endeavor. But if we turn knobs one at a time, it sort of becomes like a principal component style analysis, and we can, empirically figure out by using LISA analysis tools as a filter on the input populations, which of those knobs are the principal components, and maybe focus just on that part of parameter space at first to get like the leading order effects, and then work our way down the list. I'm probably oversimplifying things, but I think it would be really interesting just to hold everything fixed and just mess around with the common envelope coefficient and just see what pops out. I mean, we have no idea.
So let me add a comment into this. I think something that you said a few minutes ago probably is critical in my mind, Tyson, which is, you know, that all can be done from any of these codes going back through the LDC or the LISA analysis community, if we have an agreement on what the output and common parameters and formats need to be, so that we can just do those things when they happen. Like a lot of the things we certainly struggle with right now is just having to kind of constantly transform everything into common language. So maybe I mean, to Sylvia's earlier point about there being things to do that smaller groups can work on, that may enable some of this to happen one way or the other. Stas, your hand is up. But you're muted, buddy.
Sorry, I think maybe Heis wants to reply to Tyson, and then maybe I go.
Oh, sorry. Yes, sorry. Heis, I see you up too now. So
Yeah, so I actually wanted to reply, and so the first caution is that the experience is that unfortunately these knobs are not independent, and so unfortunately it's not really a principal component type thing. On the other hand, it doesn't mean it's useless, and so I think that actually one of the discussions we should try to come to something of a conclusion is that I think there is a possible step in between the steps we have in mind here. Step one being writing down what's in the literature and figuring out whether it's mainly the galaxy model that is the big difference, or whether really the binaries is very different, etc. And a, you know, in some way systematic comparison of codes, maybe at a low level. Of course, an in-between step we could do is say we take a number of codes to which we have access, and we start doing rather than 1 or 2 simulations, we do 10 different ones with different assumptions about common envelope or whatever, and we look at the output, how much is differing. I think that's a step in between, which might be doable on, say, sort of a half-a-year timescale, maybe, if you have somebody who knows how to run these codes, and if you limit the number of knobs you turn.
do we know for the various codes, do we know how long it takes them to run from input to final galaxy? I mean, I know for Cosmic, but I don't know the other codes.
Depends on the size of the binaries you run, but I mean, it can be really fast actually. I mean, you can run things within at most days.
Okay, so then when we're talking, when you say, you know, 6 months or something, Heis, that's really, that's not limited by computing time, that's limited by humans interfacing time.
Yeah, and trying and changing things, yeah, because there's many parameters to vary as well.
Okay, good, yeah. Let's see, Stas, back to you, I guess.
Yeah, I have very similar question, which was inspired by this conversation. Can you turn all your knobs up or down to actually make the maximum volume or minimum volume in terms of the bump, you know, to make a maximum bump possible and minimum bump possible, and staying within some kind of realistic, what would you call realistic conditions, not going into over optimistic or over pessimistic assumptions?
Yeah, we can, but we're doing this right now, just taking the boundaries of the error bars on every parameter and just turning them all the way over as far as you can. So we don't know what the answer is yet, but it's certainly possible to do, right? So let's see, Heis.
Yeah, sorry. So I'm replying to this. Yes, of course, this can be done, but I think it's a very bad idea. And the reason is that the limits you'll find will be very, very clearly inconsistent with what we already know. And so
but that means the error bars aren't what they are then, right?
Well, so I don't think, and the point comes back to, and you know, maybe other people may have different opinions. I don't think that the population synthesis codes we have at the moment are sufficiently understood that they can be used as an independent tool to make predictions about the universe. They're
Ah,
extremely
yes.
useful tool to explore different aspects of how binary evolution could work within the boundary conditions that we know that exist. And so I think it's probably possible to come up with a set of assumptions in any of our codes that would produce 10 times more double white dwarfs or 100 times fewer in the LISA band. But I think, you know, from work, for instance, by Tom and others, we know roughly that it's of the order of 10% of all the white dwarfs that is in a closed binary white dwarf. And so you can't go to 99%, and you can also not go to less than 1%.
Yeah, so I'll just respond to that and then Alexi. But yeah, I agree with that, Heis. I think the part of that I find interesting is there are good constraints that somehow aren't captured by the parameters that go into the pop synth codes. And so that discerning that, I think, is an interesting question. And in my head, it always goes back to what Tom was saying at the beginning, which is, you know, there are good observational constraints and there are bad observational constraints. And how do we fold those into what comes out of our pop synth codes? Because I think the parameters that we have knobs on and the error bars on them somehow don't intersect, or it's poorly understood how they intersect with the current observations and the current observational biases. So, but that's to our earlier discussion, that's probably a completely separate project. So Alexi.
Yeah, I would just like to add that, I mean, this whole idea of sort of like finding the optimal parameters that explain observations is almost like the backbone of the compass group approach. I mean, and the point is that, I mean, I think it's statistically reasonably well defined that, you know, if you want to explain, so if you want to compare how your code predicts the population 1, population 2, population 3, and different properties of those populations, then some set of parameters will do it better. So, and then if you find those parameters, it's kind of informational in some sense. And then if you find a different model and the uncertainty is decreased, then probably this different model is also better. So I mean, this whole process that you could kind of find eventually a really good model which explains all the available observations. So I mean, I think that's reasonably well defined.
Hand in the room, is that I don't know who it is, Valeria maybe? So
yeah, that's me. So may I think it still will be collaboration between all three subgroups present here. So observers, modelers, and LISA data analysis experts, because okay, for instance, we can switch on and switch off the background simply by even, there are some parameters that can do that very easily. For instance, the common envelope efficiency, if I increase it, I merge all my double white dwarfs very fast, and there will be no double white dwarfs left and when the LISA will be flying. So that, for instance, one parameter that can switch everything on and off. But there are, of course, some parameters that are interlinked. Some other ones, for instance, binary fraction, similarly, right? If we assume that there are only, that double white dwarfs are only 1% of all the white dwarfs, the background will be very low. If we assume it is 20, it will be high. So we still need some of the inputs from the observers in here, where like the extremes that we should explore.
Yeah.
And yes, I'm sure it will start just with the literature review, and we will quickly end up with the list of parameters that can do that, because some papers has already done part of the work.
okay, other comments?
Well, maybe just to be practical, I mean, I'm still in favor of this literature search business. We'll see if there's somebody signs up. I think another thing we could do is simply put out a call to all the people in making population synthesis code, saying, A, we're thinking of some kind of code comparison, which is not at the level of, line by line, but at the level of a global comparison. But as a first step, we invite everybody who's interested to explore a little bit their sort of standard range of assumptions in terms of producing a LISA double white dwarf foreground, and we provide tools or links or a recipe for how to actually get from a double white dwarf with a certain masses and distance to a LISA signal. Because I think that's a step that some groups may not be, familiar with how to do.
Yeah, or able to do at different levels of fidelity. So yeah.
And that also guarantees something I think Valeria said yesterday very rightly, that we don't want any factors of n difference between the foreground, because people have done the data analysis in a different way.
Right. Yeah, exactly. And we constantly fight uphill against that, even those of us who do it all the time. So Tyson.
So there are at least two versions, I think both open source, probably both very poorly supported and documented, but hey, open source is half the battle, of codes that you can feed it a population and it will spit out the number of detectable binaries and an estimate for the confusion noise. I have one, I know SAS has one, they basically do the same thing. And so one could say all we need to do is write some decent documentation to wrap around these open source tools, and when we make this call to the pop synth folks, say, please use this tool to assess your LISA population, and that way it's a standard way of doing the analysis. And it could be wrong, but at least it's commonly wrong amongst everyone.
No, I think that's an essential part of this, is agreeing on how we're going to do the analysis and everyone doing the same thing. So tools that are documented well enough and format to input that we all agree we can get to from our pop synth codes is I think the foundation for that, and necessary to make this project work one way or the other. And so if it's comparison through LISA observables, then so much more the bonus for LISA, right? Other comments? I didn't see who went first, Alexei or Heis. So Alexei, you're on top of my list. So why don't you go first?
It's good to have a name starting with B and A. Yes. I guess it's probably one of the next practical steps. It would be good to define exactly the people who will be working with codes and people who will be working with literature and just the whole team. And maybe also it would be good to set up a Slack channel for this specific project. And also on top of that, I had a question really, if we can invite for the project also people outside of the LISA community, which potentially could be sometimes useful, maybe.
Certainly before the end of today, we would like to kind of start having people claim to do activities. So that will be something we'll get to here before the end. As far as people outside, the discussion that we've had is that we are open to that and willing to do that. Right now, there's nothing we're doing that's proprietary to LISA that should prevent that. And so if we have colleagues outside the consortium, we should certainly reach out and encourage them to participate, because we need their expertise to do this. We will discuss later whether or not that's pathways that we should encourage them to join the consortium or not, but we don't want people to not participate because they feel like there's some barrier because of membership in the consortium. So, okay. Heis.
Yeah, so first on that last point, I do think we should encourage people to join, because I think the associate member threshold is low enough that, but anyway, that we can come to that. So there's one warning I want to make, is that for this thing where we basically ask people to just run their codes a few times and then look at the foregrounds. The thing that typically happens is that all kind of weird things start happening. And then you have to look in your code, where does it come from? Oh, this is interesting. There's this channel of binary evolution, which I had never looked at in detail before. And so this is something that get spiral out of hand very quickly.
Very rapidly.
Not a reason not to do it, but I think we should be, especially the people who have not been in this business before, they shouldn't expect that, you know, you write down a set of assumptions and then you get a set of foregrounds that are all, you know, gradually, nicely changing a little bit in shape and in level, and then you have a nice error bar on your foreground or anything.
Sylvia.
Yeah, I have to say I'm a little bit pessimistic on this, guys. I feel like this plan of just running a few systems and seeing what the different codes then pop out or different populations was tried many, many times, and I don't think I've ever seen anything really useful coming out of it. What I'm afraid of is that we're trying to understand why we get different detections, different numbers for the detections in Lisa. Okay, so we do a simulation, then we plot the data, and it's like, oh, okay, so your code produces more systems in the Lisa band, and the other one produces less systems in the Lisa band. Okay, I mean, that's a little bit of an obvious conclusion that we probably could already draw from the difference in the numbers. And then it's very hard actually to, from there, then take it into anything actually useful that we learn. I feel like, I'm just a little bit pessimistic about this approach. Sorry.
So can I just ping you a little bit on that, Sylvia, so I understand? Are you pessimistic because you think the kinds of comparisons that that we can imagine doing or that we're discussing are not going to give results that are either meaningful or convergent? Or are you pessimistic because you think the process of doing that is too difficult based on your prior experiences?
I think if we all run our own codes and then
Right.
look at the differences, we're not going to find much difference. Then we're not going to learn much new than that we already could know now based on what has been published. And then it's very hard to take it from there and learn something meaningful from it. So this is, in Popcorn, we tried so many different approaches, and it's the reason why we, in the end, ended up trying to make the same assumptions in our code as much as possible, because there were so many knobs to turn, so many underlying reasons that we just couldn't make order in all of these differences that you find. I'm
Okay.
just a bit pessimistic that running your own code and then comparing 10 output data is actually is going to tell us something.
Okay. And then my last question for you, Sylvia, is: are you naturally pessimistic all the time? Or
No, I think.
Okay, perfect.
I think I'm quite positive person.
Okay,
But it's really based on Popcorn, and also all of the generations before Popcorn that were tried, right? Even the name Popcorn doesn't come from us. It was already from an earlier iteration of the idea 10 years ago, and that wasn't the first one either.
Yeah. Okay. Well, certainly you're in my head as the person who's done this before, so I just wanted to know where you were rooted. Heis, you were next.
Yeah. So I'm also a very positive person, as everybody knows. Although I share Sylvia's worry, having seen the Popcorn struggle, I think what's a little bit different here is that, and that's one of the reasons I think that Dyson has been pushing, and it's actually consistent with what I found when starting to make the list of the literature, that there are relatively few codes that have specifically done the double white dwarf for Lisa. It's probably 3 or 4, which is already more. So I think that's why I like this literature thing, because in practice, I think most of the Lisa documentation and proposals, etc., is actually based on 1, which is even worse, right? And so I think looking at the 4 is already good. But I think in this case, if we can entice 1 or 2 other codes to actually do a double white dwarf for Lisa run, I agree with you that it will, understanding what it all means is going to be, and trying to, converge on something where we agree, or some, other type of thing. So basically, lots of these things that are discussed in this project here is going to be difficult. But one more data point just on saying, if you just run your code in the settings that you believe might be reasonably okay. And so the thing why I'm interested is that, to me, it's not clear. There could be two outcomes. One is that all the codes actually give roughly similar numbers within a factor of 2 or 3 or so. And that the differences that have been found in LISA foregrounds are mainly due to the normalization assumptions and the galaxy and how many stars are in the galaxy. Or we could find that actually there's something like a factor of 10, which would surprise me, but I don't think it's excluded. And I think that alone already gives a little bit of information. And then we have to see how many people are willing to spend significant amounts of time in understanding this. And I have to say that I'm probably not one of them. So in that sense, I may also be pessimistic.
Tyson.
Yeah, so a literature survey to see what predictions have been made before is useful, but that doesn't come with a uniform treatment of what LISA can actually observe. And so it only gets you so far. And if we were to take a handful of simulations and run them through the same assumptions about what LISA can observe and find things differ on factors of order unity, and or find things that differ on factors of order 10, both of those are extremely useful outcomes as far as our preparation for doing LISA analysis. So just knowing how big these error bars are on the LISA observable population is super, super useful. And then I understand it's like an infinite amount of work to then converge on the truth. And one way to do that is to fly LISA and measure the truth. But just to have better calibrated expectations of the range of possibilities, assuming all of the existing population prediction codes are equally valid but give different answers, is a really valuable exercise. It might not be intellectually satisfying when you end up with these very big differences for codes that you think are all basically on equal footing. I get that, but I really want that information.
Yeah, I would characterize Heiss's summary yesterday as to what we should be doing is defining those error bars that you're after. So, I mean, that was a big picture goal that I think yesterday I walked away with. Sylvia.
And let me say something more positive.
I wasn't questioning your positivity. Sylvia.
Oh no!
I was calibrating.
No, like I was pessimistic about that, but I'm more I'm positive actually and excited about the different nuance that Gijs and Tyson said. So the advantage of every code handing over their preferred version of reality for the double white dwarf population is that maybe we could distinguish between the differences in the POP-SYN versus the differences in the galactic model versus maybe the differences of how to figure out which sources are visible in LISA. So that's actually a very interesting question, and that might also be something that is relatively cheap to do, while really trying to understand every different knob in the POP-SYN is a huge project.
Yeah.
So it is. I'm excited and positive.
Okay. Other comments?
I was going to type, but speaking is faster. So one comment, Tyson, that I made yesterday, but you were not here, is that we have to be very careful with this word error bar. That's really not the right word. There could be total agreement between 4 or 5 different codes, and all of them could be equally wrong. And so it's really not an error bar. It's of course a range of outcomes of different codes.
Uncertainty, right?
No, not even uncertain. It's really only that, right? it's a range of outcomes from codes that we have no clear reason to believe are rubbish.
Ah, yes, yes. Okay. I agree with that statement.
Yep, me too. Error bar is a cheap shorthand, but you're right.
Well, and why I'm pushing on about this, of course, I've been in this gravitational wave community now for a while. And if you're not careful, people start believing that the word error bar means what they are used to, what it means. And so it's very important to make clear that there's no such thing as an error bar on a population synthesis prediction.
Yeah. Okay. That's a really good point. Oh, Alexi, I see your hand up. Yeah.
Yeah, just to continue the thought. I mean, like in the end, we want to give the brackets on reality, and I mean, it's actually good to try to kind of to list the possible things that might affect the predictions. I mean, it might be that we even are not really thinking about them. So I mean, obviously, galaxy might affect it, or communal prescriptions might affect it, but maybe that's, I don't know. I keep thinking about triples. What if the triple population is like strongly adding something to that? For example, I mean, so in the end, probably it's good to try to brainstorm and try to list all the possible sources of uncertainty beyond what we thought about. I mean, anti-correlation of binarity with metallicity or some kind of other things. I mean, there's a lot of like possible things, for example.
Yeah. Okay. Anything else? Okay. So we have a lot of quiet folks here who are just listening in. Is there anything anyone would like to ask or follow up on or bring up before we move on to figuring out what we should do? Okay. Stephen's shaking his head. I assume Astrid is as well. Okay. Okay. Yeah, so there's been a lot of discussion. We took notes yesterday. We will add notes from today as well. There will be recordings. There are recordings of these events, so we can certainly go back and listen again and ponder some more if people find that useful, instead of listening to podcasts or whatever you do when you commute to work normally. So I think maybe the other thing I wanted to make sure we return to today is that we walk away with some names down. Certainly something that we are still looking for is someone who's interested enough to coordinate the effort. But there are also lots of small tasks here that I think people can adopt before the effort is fully defined and someone starts us down the path of doing the kind of big parts of the project. So the literature comparison and things like that, I think are the sorts of things I have in mind there. Certainly those of us who have codes in place, listening to this conversation, certainly for myself, there are parts of this where I can imagine there are things we should start doing if we're going to use Cosmic as part of this effort. And so there's probably work to be done there, just to lay groundwork for getting interfaces in place and those sorts of things. So enumerating kind of what those are, or getting a small group of people to talk about what interfaces might look like as the project kind of settles in and becomes more defined is another small thing in my mind that probably can be done before we're fully organized. So I think I'd like to spend the kind of last half hour here is let's just talk about tasks, let's talk about names, and let's talk about how we continue this after the working group meeting's over. So when do we meet again? When should we chat? What kind of targets for having something done and coming back and having this conversation again should be? So yeah, so why don't we start with just pointing at the tasks that does anyone have anything else they think we should add to that before I kind of leap into it? Something I forgot that we should do?
Sounds like a good plan.
Yeah, okay. I'll take my co-chair's support as being okay. So let's just remind people of some of the things yesterday that we had said. So in particular, the literature search was something that was done. I don't think anyone needs to be necessarily responsible for that, but I think the links in the document that is being shared right now, Thomas, is that, I think, I can't remember where it was. Maybe it was that in the header of one of the, yeah, there you go. Yeah, so if you click on that, that was, that links to a Google Doc that Heis created yesterday for assembling literature. It's just a listing of the literatures that we know of where LISA studies have been done and documented, and links to the papers. So as Heis said, there's probably a limited number of those, but it would be good to have them all in one place so that we have a assessment of what the what's been done and certainly what people rely on. I would add to that something I think would be valuable, maybe from Tyson and Stas or people who are involved in the LDC, is the addition to that of knowledge of which versions or which models have been used in kind of full-blown LISA analyses in the past. I think just surveying the literature, there's been plenty of assessments made, but I don't know which ones have had kind of the kind of most aggressive use or referential use, let's say, by the LISA project. So that would be useful to have in the literature search as well. So anyway, so like I said, I don't think anyone needs to be responsible for this per se. As long as people know this is here and they go back to it and they add to it, that would be the most valuable. Right now, there's no subheadings here by topical matter. If people have favored papers that are tangential to this or related to this and want to start subheadings farther down the document, please go ahead. We'll have to get to all of that eventually, but I think at zeroth order, the beginning here was what Heis has written up there at the top, which is predictions relevant for the LISA signals. Okay. And then I think maybe the other thing that is not here that I would add or like to see a header for is literature about the known binaries that where we have data or predictions about them. So I'm thinking mostly about the Gaia paper that you led, Thomas. Those sorts of things need to be in there as well. So.
Yeah, exactly. We can link the GitLab page which we created. We're actually about to update it with DR3 data. I will do this as soon as I'm back. So that will be next week, and then I can link it in that as well. Okay, yeah. So maybe related to this then is a document with links to resources like that, because actually I'd forgotten that GitLab page existed. But yeah, so okay. Okay, any comments or questions or suggestions about the literature study bit? Lexi, your hand's up.
Yeah, so I'd say that it's probably good if everybody collectively assembles the literature list, which is very good. But at some point, it would be good to extract the useful information from all this literature, and probably then to be good to define some people who do that. Because I mean, and also define what we want to extract from the literature. So probably maybe at one of the next meetings. But probably will require work of I don't know, 3, 4, 5 people.
Yeah, I think that last part's the part that's probably the obstacle there, is we don't know what we want out of it yet. But yes, absolutely. Just having literature is just the beginning. So yes, very good point. Other comments?
How about making a summer sort of journal club or study club in which we try to go through them together, and some people can volunteer and present some papers so that we, discuss them.
The authors of the papers could present their papers.
Or there are some earlier papers that, somebody can also read and summarize, but we split the work at least in this way. Yeah,
I think that's a good idea. If people have time over the summer, I would certainly participate. So.
But what Alexei said, I think, is crucial. Like a smaller group of people should come up with a list of information that needs to be extracted and codified.
Yeah.
Yeah, I guess they, Alexei plus whoever this group is, can start with some table suggestion, and the next time or the time we meet, we can discuss it.
Yeah, I think that's a good plan. Someone just start with a straw proposal and then we can argue with the straw proposal afterwards. So that's a good idea.
I'm reading there about Floor. I would also second inviting her.
She's already in the loop.
Okay. Okay, so the code coordinators there. Sorry, anything else about the literature before I move on to the code coordinators? Okay, so Thomas, you were commenting about Floor. I missed what Valeria responded to that.
It just, we said here in the room that Flor would be a good person to have on board, and she seems to be enthusiastic about this, and she's already in the loop.
Okay. Okay, great. I sent an email to Ash. So Ash, we had mentioned as likely as a good candidate to represent Compass. She responded that she was not, but she was interested and would like to use Compass more. She said her graduate student certainly knew more about using Compass than her, but was worried about the kind of amount of stuff on his plate. And so she suggested and CC'd Ilya Mandel. And Ilya hasn't responded to that ping from Ash yet, so I haven't heard anything. I also reached out to Katie. I mean, in as much as we use Cosmic in my group and I run Cosmic, Katie's really the kind of central authority on Cosmic. So I have not heard back from her yet, but I will let you know when I do.
Flor would be representing Compass. So.
Compass, okay, right. Yeah. That was all as part of the Compass discussion yesterday. That's right.
And
okay.
Katie can do Cosmic, right? So that would be perfect.
Yeah. Cosmic was part of Katie's thesis. That's where it came from. So, okay. So if that were true, then it would be SIBA, Cosmic, and Compass just by virtue of who's in the room. Is there any other code that we feel really motivated that we should reach out and try and rope into this?
I would say that the only other relatively independent code out there that can do white dwarfs is Star Trek.
Yeah.
If anybody from Chris's group wants to go in that direction.
So that would be Ashley again, right?
Yeah.
So yeah, so I didn't actually ping Ashley about Star Trek, but I could.
Yes, please. Yeah, that'd be great.
Okay. I will in the chain I've been having with her, I'll respond and just ask about Star Trek. So is it anyone besides Ashley and Chris who uses Star Trek?
I think Ashley is the one that uses Star Trek most for the white dwarfs, where Chris is more focused on the neutron stars and black hole.
Okay. Okay, so maybe Star Trek added to that. So okay. Okay. So I mean, as we've been discussing, certainly there's more codes than you can shake a stick at, but if that's a good number. I feel like the 3 and 4, if we add Star Trek, is certainly more than enough, and will provide plenty of work for all of us. But does anyone have any strong opinions about what that list should look like other than those 4 we've been talking about?
Maybe we should just check in the LISA literature if there were any other codes used to make LISA predictions. So then we might rewrite that.
Yeah, and certainly for this parameter extraction that we were talking about, Alexei, we can encourage that group to do that. So, because I mean, just listing the literature, we probably will list literature that has other codes in it that we don't know about. So, yeah, that's a good point.
For this,
other comments?
I added ours to the list, and Stas, if you're still on the line, you should add yours.
Sorry, I missed that, Tyson. You added what to the list?
LISA analysis tools.
Oh, perfect. Okay, great. Yeah.
Stas has a version that does the same thing, but probably better.
Okay. Yeah, is that in the document we're staring at on screen right now? You put that?
Yep, in the list of codes
Okay.
at the bottom.
Okay, so we should separate these a little bit. Yeah, let's make a separate header for Lisa analysis codes. And then we can keep them distinct from the PopSynth codes. Okay, perfect. Okay, thank you, Tyson. That's helpful. I know Michael Katz has a package as well, so I will add his. I'll dig it up after the call here, and I'll add his tools as well. And Stas, is Stas still here? He is. You'll add the figure of merit link or whatever you're going to put there.
Yeah, sure. I mean, yes. Maybe we can make a bit even better extraction specifically for this from figures of merit. But always the question is of interface. So what the code does, it's estimating foreground, so basically the stochastic part, and also can do Fisher matrix estimation for the resources. Okay,
rock and roll.
Shane, may I add for the DPS codes? I think there is also a group from China and that did Lisa work with the white dwarfs, and I think they focused on ELM white dwarfs.
Yeah,
but I don't since I have my laptop. I don't remember the name.
That's
Sylvia, maybe
that's the Kunming group, right?
Huh?
Is that the group in Kunming?
I don't remember.
Yeah, like Bo Wang, Swanson Han,
Yeah.
and all of their group members.
Okay, can we put a placeholder for them in the list, and then when we get the link, we can add it?
And they typically work with BSE or BSE related.
Oh, they use BSE. Okay.
And they historically have done a lot of hot subproof work.
Okay. Yeah. So we should definitely add them. Certainly the Chinese community is very active. And they are always, in my experience, want to be very collaborative on this sort of stuff when they can. So,
and they definitely have some DAISYCO papers and the other. So there's definitely interest on the gravitational wave side too.
Yeah. Okay.
The dwarfs and the foreground as well. I think they have to.
And I think Thomas Tauris knows some of them, so we could maybe ask him to connect.
Okay. Okay, that's a good thought. So let's put a placeholder for them in the list. Maybe someone add just to ping Thomas. Okay. Other comments on either analysis codes or?
I thought that Andres put a really good comment in the chat. Maybe we can.
Sorry, I just and directly to you because I'm not part of this collaboration, and also not so sure about this long systems. But I just pointed out that I think most of the codes that so far you have chosen use the same stellar checks apparently. So I'm not sure about the uncertainties in the stellar checks for these lower systems, but maybe you guys should choose a code which use some different descriptions of that. For example, BPass or the combined. Regarding how the single stellar checks. So I mean, that's why I told you.
Interestingly enough, I think what's his name, Kukov, that developed it in the first place. He's now in the Kunming group in China.
Ah, okay. Okay. Other comments? Okay. Okay, so let's see here. So we'll, those of us who have been tasked with, let's continue to reach out to the people for the various code representations here. Update the document as you hear from people, just so we know. If Floor is enthusiastic, then maybe we should move her and Compass up to the list up there in the 1, 2, 3 bit. And then we'll put the others in as they confirm. Okay, I think that's maybe all at the moment with the codes. Sorry?
No,
Like-
I was just saying to Thomas, because I'm not sure if Laura confirmed to be a coordinator. She's definitely enthusiastic.
That's
to
enough.
know.
That's enough.
Okay, that's a good
Yeah,
point,
yeah,
though,
yeah.
Valeria. Yes.
She didn't.
If somebody's
Yeah.
enthusiastic,
Yeah.
right?
So we
So
should have
sorry, Stephen, were you agreeing or disagreeing?
She agreed to talk more about it. Like, she's very enthusiastic about these BPS code comparisons in principle, right? She's been talking about wanting to do one for a while.
Okay.
So I think she'd be enthusiastic, right? But I think we need to talk to her.
Okay. Okay.
He definitely
Well,
hasn't
well, in as much
finally
as,
agreed.
you know, this list of people are the people who really are going to be the, what I was going to say is they're really responsible for the individual codes in the project, maybe not for guiding everything that's going on. So if there's concern about the lift of managing the whole project here, then we should talk about the scope of what people on this particular list we're expecting them to do, right?
Yeah.
Okay.
I mean, we should also make sure that they get credit for whatever they do, of course.
Absolutely, yes. And as we discussed yesterday, I think my takeaway from yesterday's discussion was that the names on this list will be among the lead authors on the paper because they're responsible for the codes, right? Okay.
Another great thing about Flora is that if she agrees to do it, she'll also be a fantastic organizer.
Okay, good.
Yeah.
I've not met Flora, so I don't know her well. So, okay. Other questions or comments? Okay. Okay. Sylvia, I was just scanning the chat. You said there was a comment from Andres that we needed to address or that we should remember.
Oh, but we just talked about that.
Oh,
That was
okay.
The point that the codes so far are all based on the same stellar evolution tracks.
Right. Okay. I don't see that in the chat. So, okay. Yeah.
Oh, sorry. I think he only sent that to me.
Oh, you spilled the beans. Okay.
Yeah.
It's okay. It's good. Yeah.
But he mentioned
It's a
it.
good comment, right? It's one that I think we have to bear in mind. Yeah. Okay. Okay. Anything else? We good on this point for the moment? Okay. So then in terms of kind of coordinators for the project, for the moment, right, the chairs are guiding the conversation here. But I think our intent was always for there to be another coordinator from within the working group who's enthusiastic about moving the project along. So I think we still need names here. And Thomas is laughing. Why are you laughing? Or Tazos is laughing. Why are you laughing, Tazos?
Enthusiastic people.
Oh, yes, right. Okay. So we still need names here. And if someone within the group is being shy about volunteering for coordinating, you certainly are welcome to reach out to Valeria or I and volunteer serendipitously. But if there are suggestions of names for people that we might approach and do a little enticing to, then I'm certainly happy to hear suggestions for facilitators here as well. We did think that it should not be a graduate student. Graduate students have enough on their plate, although we're certainly happy for graduate students to participate. But a postdoc or someone who's early in their career certainly would not be out of consideration. So everyone should stew on that. Or Valeria and I will be stuck doing this for a year. And then you'll have to listen to me all the time, so, or Valeria all the time.
No, I'm an introvert person. I like to listen.
But Shane will do that for you.
No, I am an introvert too. Don't do that. Okay.
I'm for sure.
Yeah. Well, I'm going to volunteer Thomas Cooper, so there you go. Okay.
I'm not useful for that stuff. I'm not a serious.
We need someone who knows nothing about the codes to coordinate the project because they have the most objective view of it. So
I'm as useful as a monkey pressing the start button.
Okay. Well, we will come back to that point. Please do, everyone, think about that. And then we will slowly coalesce around someone who kind of makes sure things move along week to week. We got about 10 minutes left, so I think maybe the one thing I definitely want to do before the end is talk about how we should regularly communicate about this. So in as much as all of us have plenty of telecons that we have to do, I do think meeting in person and talking is often, or virtually in person, is often more efficient than leaving things to email. So I'd certainly be in favor of having regular calls, at least up till the summer holiday, just to kind of keep us moving along until then. And then we can make a plan once the academic year in the Northern Hemisphere starts again. So
regular calls help to keep the ball rolling. It's just right, regular calls here it helps to keep the ball rolling, right?
Absolutely. Yeah. Okay. Okay. Oh, sorry, go ahead, Valeria.
I heard that the circumbinary disks and Emory related project will be starting probably from September. We mentioned something like summer literature club.
Yeah.
Do you think, like, should we decide whether we should start following up soonish in summer, or should we?
Well, I can express an opinion, which is that, any momentum on work, which requires fingers on keyboards, will be stalled by the summer holidays. So something lightweight like the summer literature club would keep things rolling and put data that's needed for actual work to start on the table. And then when the academic year starts, we can start regular calls where we're tasking people with work. That sounds like a fine strategy to me, but I'm open to other suggestions.
Wait, you're saying postdocs have summer holidays?
I'm saying Europeans have summer holidays.
Oh, that's right. They're lazy. It's true.
We don't believe in holidays in the United States.
Exactly.
You just checked.
Okay. Well, I like the idea of the summer literature survey. And then related to that, a small group of us, which I think maybe Alexi and certainly I'm interested in extracting from the individual literature what's there as part of that summer survey. I think those will go hand in hand. So we could just make those the goal for end of summer, and then when the end of summer gets here, we'll continue in addition to kind of pinning down pop synth people here for each of the codes. But then I think Valeria and I at the moment are probably on the hook for organizing regular calls once fall gets here to keep things moving. So sound okay, Valeria? So.
Yeah, if I may add one point is also, I mean, I think steering the whole thing is one thing and throwing the codes is a different thing. So it's probably good to be clear about sort of like which person make sure the things are happening and make sure that the things come together, and which people run different codes. And so I guess probably good to, like, when you talk to people, good to define that.
Yes. Yeah, and that absolutely, I think, is a distinction in my head, Alexi, and this kind of coordinator liaison person here that we're staring at on the screen is the latter, not the people necessarily responsible for the codes. Although one of them is certainly welcome to volunteer. But for the moment, I think until we have a name there, Valeria and I will make sure things kind of roll along and we check in with people.
So I'll be making sure to talk to you and Valeria and then to make sure that things are
I think that's fine. I think maybe related to that, I also would just like to make sure that on the pre-LISA EM side that we have some regular contact with them. Several of us in the group here are also working on that, so maybe we don't need to worry about that formally, but I wanted to just say it out loud because I think there's a lot of overlapping work over there. So, okay. Okay, so we're near the end. So Valeria and I will figure out what to do about having the summer reading. We'll try and send a note to everyone who's expressed interest in this project, and then we'll get that rolling before too long. Anything else we should talk about before we have to go? Yeah, Tyson says the clock is ticking. Yes, absolutely. I agree with Tyson.
Maybe one last thing. So, I mean, I think it's also good for sort of the coordinator role to have at least somebody from observational community to not be too biased towards modeling. So, I mean, I would actually try to encourage the team to find somebody from observations who would be interested to follow the sort of the process and kind of.
We'll make sure to tell you if you do things wrong. I'm serious.
Thomas does that all the time.
Of course, that's our job, right? Isn't that? And on a serious note, I'm still, as I said, we'll put together a document which has some boundary conditions in place, and then whether you use them or not, that's a different story. But at least some boundary conditions. Like I can work with Jan, who's anyway leading project 3, which is really along those lines. And I just volunteered Jan for that, so that's fine.
Okay. Any other observers have comments or want to volunteer for any of those kinds of activities?
I wanted to mention that we discussed that we should maybe then, once the two projects are rolling, so pre-release AM and this one, we will we should update each other. So maybe that will be the time and place to check.
Exactly.
Yeah, maybe regular cross reports would be useful. Yeah.
There's probably anyway a lot of people overlap. So yeah, exactly. That's but yeah, that's a good thing to keep in mind.
Yeah, I mean, in as much as there's overlap, that means people know stuff, but I think it's useful to say it out loud for everyone sometimes. So, okay. Well, I think that's probably near the end. So this we'll formalize how to keep track of everything, but we'll keep minutes and lists like we are in Google Documents, but we'll probably on the Lisa Wiki, we'll put links to all of them so people can find them, but we'll certainly circulate it in email for those people who rely on email search functions to find old things. So we'll make sure that happens, and we'll be in touch in the near future. And otherwise, I think we can call it good and take a break before the next session in 5 minutes. We good?
In 35 minutes.
Oh, break after this. Thanks. I don't have the schedule in front of me. I just knew we were done at the top of the hour. So, okay.
I'm actually very impressed by you. You're actually at every day from the beginning, like which is 2:30 for you, right? When we start.
Yeah. So I rotated my clock at the start of the week. So, okay. Well, sounds good, everyone. Thank you so much for your participation. It's a big task, and there's lots to discuss and still sort out, but it's helpful to have everyone here and kind of putting their brains on the project. So I appreciate everyone participating. This is great work, and we will see how we progress in the next few months. Okay, rock and roll, everyone. See you in 35 minutes, right, Valeria?
Yes.
Okay, bye-bye.
Bye.